we're going to move right along with another example of new manufacturing from the front lines. And I'm particularly excited for this next speaker, Charly Mwangi, who has really seen multiple examples through his career of new manufacturing excellence. So he started his career at Nissan as a manufacturing engineer and then moved on to Tesla, helping lead manufacturing and the launch of the Model S and then the Model 3. I would say took a break from traditional manufacturing to set up the infrastructure for Cloud Kitchen, was a food delivery startup, and helping scale that. And then before becoming a venture capitalist, investing in new industrial startups, he led manufacturing at Rivian, which if you haven't seen the videos online of Rivian's normal factory and their production lines for both their passenger vehicles, but also their Amazon delivery vans, it's really remarkable. And I think a lot of the lessons from these companies can help build a paradigm for new manufacturing. So please welcome Charly to share what he sees as a 000 framework for manufacturing. Thanks, Charly.
Thanks, Ben. It's really good to be here. Thanks, John, for having me. Super excited. It's rare to be among people so excited about manufacturing, so really excited to be here. I should really start by saying I agree with everything Susan just said. I should just really go straight to Q&A. And you'll see as I get into my topics, you'll see how much they align with everything that Susan said. So Susan talked about this, right? The last 30 years, manufacturing has actually been moving from west to east. And now we're starting to see manufacturing swimming against the current. And what I mean by that is manufacturing historically has always gone from high labor cost to low labor cost, from shortage of labor to abundance of labor, always flowing towards consolidation in pursuit for economies of scale. And for the first time, we're swimming against the current. And by definition, that means that manufacturing is going to look different. And so what I want to talk about is sort of like a framework, spend the next 15 minutes or so talking about a framework that we built over time through really painful lessons through my time at Tesla, and also experimentation, adventurous experimentation, and successes as well. And then number two, I want to share what that framework looks like when you're thinking about next-gen factories. And then I'll finish off by just highlighting one example. I can go into a second one if we have time, but just an example of actually applying that framework in practice. And so let me start with a controversial punchline here. Next-gen factory is no factory, right? And does everyone agree? That's a controversial topic. Does everyone agree? If everyone agrees, we can just stop here. What's that? Exactly, but that's what I'm saying. Next-gen factory is no factory. Everyone agree? No, you don't? Exactly. Actually, you talked about this, right? And this is what I'm going to get into. The world doesn't need more factories, right? Controversial topic in the middle of manufacturing symposium, right? But we're going to build them anyway, right? And so what I'm talking about here is acknowledging that this doesn't mean that we don't build manufacturing capacity or we build factories, but we have to be really intentional and measured in how we approach it. And it's about what you talked about. Less is actually more. And it's doing a lot with less. And this is really what I want to talk about. And 000 framework is about being intentional and fundamentals driven as you build manufacturing capacity. So in true African fashion, I'm an African, so I'll start with some stories here. Oh, you can't hear, the audio is on, it's not on. But this is September 29th, 2015. And what you're seeing there is the handover of the first 10 or so Model X's to their customers. What you can see, and I was hoping the audio would be on, is a bunch of us in the background hugging and crying because this is the first time we saw those doors open flawlessly, right? And this was at the reveal. And what Model X highlighted was, have you ever seen that meme where someone says, "Hold my beer"? I think someone at Tesla said manufacturing is easy, and Model X said, "Hold my beer." Right? Let me show you how difficult manufacturing can be. To this day, this is the most difficult product I've ever worked on from a manufacturing perspective. And really, there's a lot of hubris on our part where we say, let's design a product, forget about manufacturing, we'll figure out how to manufacture post-designing the product. And this vehicle almost brought the companies to its knees. And it forced us to step back and acknowledge, hey, as you're designing a product, you really need to think about manufacturing and design that in parallel. So we took that into consideration when we were designing the next product, which was Model 3, in terms of simplifying the product. So what you're seeing is the Model 3. This is what's called a framing line. So while we took lessons in terms of simplifying a product and making it simpler to manufacture, we oversteered on the design of the machine that builds a machine, which is the manufacturing line. And you guys had famously heard of production hell. This was in the midst of production hell. This is in October of 2017. And the lessons that we were learning, painful lessons, was that, hey, we need to step back and think about automation. A lot of people here talked about, the future of manufacturing is automation. You have to be deliberate about it. And we missed in painful ways. But in the midst of this pain, we actually stepped back the company and started thinking about, hey, let's think about not just the product, but the machine, design of the machine that builds a machine, and think about like, hey, how do we design these systems going forward? And really, this was the beginning of an interesting journey of rethinking manufacturing. And so when we step back, again, during production hell, during pain is actually the best time to think about things from a fundamentals perspective. As we step back, we thought about manufacturing, building of manufacturing capacity as being like 3 distinct phases. And all of them have interesting variables, and sometimes those variables are in tension with each other. And so the first phase is going from 0 to 1, from I have an idea to I'm actually building a product that is customer sellable, right? Then the second phase is going from I can build one thing to I can build at scale. And frankly, this is where many companies die. Call it the valley of death, right? I talk to a lot of startups today, and they can go from 0 to 1, but then going from 1 to scale is where most people just can't figure it out. And then the last phase is obviously when you're in production, right? And so our goal here was thinking about questioning each one of the different phases and thinking about like what should be our target for these phases as you're building new manufacturing capacity, right? What should be, and historically what people had done is saying, well, I'm going to be 10% faster, right? And we just thought that that would not force us to go into and think about things from a fundamentals perspective. So we started questioning everything, and we came up with what seemed like a really controversial but also aggressive, sort of like a North Star. And that goal was what we call 000, but it was thinking the ideal North Star for each one of these phases is 0 to 1, we wanted 0 lead time, 0 RAM time, and 0 downtime. That's your theoretical North Star. Really, you could add many others, right? During our time, we had 0 CapEx also as a constraint, but 000 just sounded cooler, so we stuck with 000. But the whole idea here is we wanted a framework to evaluate all the variables that influence manufacturing, and then always go back to our North Star and say every step, again, going back to being intentional and deliberate, every step, every technology, every process we're adapting, is it getting us closer to 000? So the framework was a forcing function for us to think about manufacturing from our first principles. And so we stepped back, looked at a variety of variables, And again, always looking at, this is where we are, every one of these variables, how does it influence us in getting us closer to 000? Again, when you're designing manufacturing systems. So again, we looked at things like, hey, if our automation was to move faster, does that get us closer to 000? We looked at part content. We looked at velocity of transfer in automated systems. We looked at manual processes, all sorts of variables that influence manufacturing. And the goal is we were trying to identify the most leveraged levers in terms of getting us closer to 000 framework. And so, as an example here, let's see. So we didn't advance. There we go. So as an example, as we looked at a variety of variables within manufacturing and playing with each one of them and seeing how they influence manufacturing, we actually landed on something that seems so obvious when you talk about it, but actually not usually practiced. And this was content reduction, right? And the whole idea here was we found that if you reduce content in manufacturing, it actually, each one of those phases I talked about, it significantly simplifies the manufacturing processes. It reduces lead time, reduces ramp time, and definitely reduces the risk of downtime during manufacturing. And content reduction seems so simple. And so we started playing around with the idea of content reduction. And we came across an exception, right? That, the example I like to use is if I give two people the problem of building a table, something like this. I give one person 1,000 parts to build this table, and then I give the other person 10 parts. The person using 1,000 parts will never, ever be able to catch up with the person doing 10 parts. And it becomes more elaborate and the difference is even larger if you have to consider the design of those parts, the sourcing of those parts. There's no way the person building with 1,000 will ever keep up with someone doing 10. But then we found an interesting exception, which became another constraint that we use today as we think about building manufacturing capacity. And that exception was the length of the value chain of a particular part or content. What I mean by that is, again, if you take the same 10 parts, if each one of the 10 parts requires a process that has 1,000 steps, but there are 1,000 parts require a process that has one step, again, then the dynamics change. So the whole idea here was we identified these two variables is that, yes, we wanted part consolidation, again, elimination, reduction of content, but we also wanted processes for making those parts that have the shortest value chain. And so the example I use here is in Model 3, where again, we're in the midst of production. This is actually when we got the insight of one, part consolidation, and then looked for what process would we use for part consolidation and identified castings. And what you're seeing on your right there is a Model Y, which architecturally very, very similar to Model 3, but we consolidated a bunch of parts. And what you're seeing there at the back, where we started actually at the back, where we actually had 180 parts, 180 robots, building the Model 3 structure. And at the back, those robots were replaced with just one piece of machine, which was a casting machine. So the whole idea here is the content reduction, short value chain was a huge enabler in terms of pulling manufacturing, whether it's ramp time, the lead time, pushing it to the left closer to 000, right? And that's what you see. And the difference between those two lines that you're seeing in terms of the graph of ramp, the difference between the area of those two is just like revenue. This is solid revenue that the company is able to pull ahead. And so this is a good example of 000 framework in application, but 000 framework is broad. This can be applied not just in part consolidation, I'm talking about process elimination, I'm talking about many other, so evaluation of many other variables, efforts, R&D areas of focus, again, you always go back to this framework and saying, is it getting you closer to 000? So an iteration of this is as I went from Tesla, I went to Rivian, we're able to do the same thing. Pick up on projects, decide which areas we're going to focus on. Even from a technology perspective, we always went back to 000. Is it actually getting us closer to that? And so I don't know how many minutes I have, but going back to the conclusion, the question that you asked, right? Like, what is this? Is the best part is no part. Most people have had that. Best process is no process. And the idea here is going back to the fundamentals and questioning each and every step. We have a rare opportunity now to rebuild manufacturing. And we cannot do it like we did 30 years ago. And by definition, the constraints are very different, right? So we have high cost of labor. We have a shortage of labor. So we have to figure out, and we're going to have the scale that was consolidated in China. And so we have to eke out productivity from different areas. And I think the opportunity we have is this rare opportunity not to start where manufacturing was 30 years ago, either where it is today in the East, but to actually extrapolate from what we've been seeing in the East and take the best practices and rebuild manufacturing thinking from a fundamentals perspective. And I think this less with more framework is actually what will lead us to build differentiated manufacturing and eke out productivity in a different environment with different constraints. So this is why I say next-gen factory is no factory, sort of like tongue-in-cheek. And I think that framework is what we have to use, sort of like going forward. And with that, I'd like to take questions. And if there are no questions.
Charly, I sense an implicit message that you never use the word, but the temporal aspect of your discussion talks about what seems to be a much higher value proposition on the aspects of time to market, versus what I would say is the traditional focus on affordability, cost reduction, profit maximization, whatever you want to be. It seems like time is the theme in your discussion. Could you expand on that a little?
Yeah, so I think the framework is based on urgency to build, I'm assuming urgency to build new manufacturing capacity. And so it's counterintuitive, but actually some of the solutions I suggest in terms of just going back to the fundamentals, and not only do they gain you time, they also gain you efficiency from a cost perspective. So in addition to time, meaning be able to pull to the left and be able to build manufacturing capacity faster, if you double click on the content I talked about, is content reduction leads to equipment reduction, leads to process reduction, leads to CapEx efficiency, right? So that there's a cost element to that. But then when you go to operations as well, it leads to operational efficiencies that you didn't otherwise have. And so, yes, one of the most tangible benefits is time, but actually there is underlying benefits there, which are costs as well. And so we, as I said, actually, with my teams, we actually used to have 4 zeros. And the fourth zero was zero CapEx. So we didn't want to spend. And so I think it's all three.
Really interesting case study with the gigacasting. I'm curious, like, what do you give up? There has to be a trade-off. And so consolidating parts in a new processing technique, something has to give. And what is that? Or is it all win?
What did we give up? I don't know that we gave up a lot. I think the initial assumption is sometimes that you hold things constant and you assume that hey, I'm trading this automation for this process that is, again, you're holding constant. But we didn't just say, hey, we're just going to go adapt this casting process, because actually casting process didn't exist for the size of parts that we wanted to make. And so there was a lot of, hey, by the way, for us to be able to adapt, here's a threshold in terms of performance. Things like we wanted to eliminate things like heat treatment. And so there has to be a fundamental differentiated approach in terms of that. And so I don't think that we gave up a lot in terms of, what people would expect is you're using proven technology in terms of, welding, cold stampings, and you go to these castings and you give up sort of like high availability. And that was not the case. It's like there was a lot of engineering time spent. And by the way, I think what we gave up was we knew that there would be a dip before we took off. And that dip was just that you're introducing a new process. Down to the equipment was invented for the process. And so we knew that there would be a dip in terms of difficulty. But again, going back to the fundamentals, and this is what was important, is that we knew at scale, even though there would be an inefficiency dip initially, we knew at scale, fundamentally, this would be a better framework and better approach and more differentiated. And so it paid off over time, but it was a painful dip. But at least we knew that the fundamentals supported what it would look like at scale.
Hi, thank you for your presentation. I have the question that, like, how did you create awareness in the product development department for like design for manufacturing? Because based off my experience, a lot of engineers in the R&D department are looking like, how can I create the perfect product? But then when it's going into the manufacturing department, it's like, okay, we need to set up now the line. But like sometimes it's like more difficult to produce the perfect product, and like how you can do you
So
have tips?
it's a really good question. And I think, someone here touched on how we are organized within manufacturing organization is just as important in terms of adapting innovation. So if you think about Model X, just to answer your question, it was a traditional organizational structure where you have a manufacturing engineering group, they're focused on the operations, and then you have a different product design team. Actually, the reflection here, going into Model 3, that was completely changed. And so going into Model 3, and this has started being adapted in a lot of companies that are doing manufacturing, there was one person responsible for the product design, the manufacturing engineering as well. And I can't overemphasize how important that is, because in many ways, it was just like one decision maker who was responsible for optimizing between the design of the product and the manufacturing systems that are building that product. And that was the biggest enabler in terms of just making sure that alignment. Again, because it's not that simple. You have to make trade-offs across the board. But I think the best way to do that is consolidation and just making sure you have that single point. But I think today, and I'll touch on this if once we get up, we get through the questions. I actually think that there is today ways of using software to enable that, right? If we have time, I'll talk about that. I'm excited about that. John and I talk about this a lot.
Hey, Charlie.
Hey, Aaron.
Hey. When you talk about shortening the value chain or preferring shorter value chains for a product, do you differentiate between a value chain that you control versus one that sits outside the organization?
No, it actually, and I think someone touched on it. It doesn't matter whether you're vertically integrated. In other words, you own that value chain. You should just look across the board, from raw material to a finished product. And if there's opportunity to consolidate that, whether it means that you adapt a different sort of like a process internally or your supplier does it, it doesn't matter. I think what you're looking at is, and this is where we have to step back and say, we want global efficiencies, not local efficiencies. So it doesn't matter. It should just be raw material to finished product. Where is the opportunity to consolidate that? I told you everything you said. We sort of like we were aligned. Yeah.
A quick question. So it sounds like this 000 is sort of lean manufacturing or continuous improvement on steroids. That's my first question. Second is, as small business owner, manufacturer, what recommendations do you have for the small manufacturers, let's say under 100 employees, for beginning their journey towards a concept of 000?
Yeah, so I don't know that I would think about it as lean manufacturing. So I spent, actually, before Nissan, I started my career at Toyota. I think there's a little bit, when we talk about lean and continuous, it's very incremental. You use sort of like relative positioning to say whether you're doing better or not. And that's, I was doing it with 100, in 100 hours, I was doing it with 100 people. Now I'm doing it with 90, and then you clap and celebrate that you've won. And 000 is about saying, I was doing it with 100. Let me start with, how do I do it with 0? And then I justify every person that I'm adding in the process. And I think there's a bit of a nuance there that is super, super important. Your last question on small manufacturers, I think the temptation is to look at the companies that are bigger and therefore more automated and say, let me follow that path. But I think that there are tools being developed here that can actually allow small manufacturers to have the efficiencies that you see in big manufacturers, and to leapfrog sort of like what has happened in the last maybe 10, 15 years. And a lot of those tools exist in the digital world, so like software. Maybe it's a good segue for me to touch on that topic as an answer to your question. I do think, we just talked about part content reduction. But I actually think one of the most leveraged levers that exist today, if you think about, again, going from 0 to 1, if you think about the lead time 0 to 1, is we design, we test, we get manufacturability feedback, and we go through those loops. And this is the primary driver for the duration from going from 0 to 1, right? It's this siloed process of designing, doing testing, and then getting feedback from manufacturing. And if you think about the tools that we're using, is emails, processes, a bunch of meetings. But then there is a second step going from 1 to scale, which is where we're ramping. And if you ask yourself, like, what's happening there? The 1 to scale is you're aligning all these variables that influence manufacturing to get them to be aligned so that you can produce this thing in a predictable way. So then if you step back, again, using the 000 framework, where are the opportunities and the levers to be able to collapse is? Today, the most leveraged lever, in addition to the things I talked about on the atom side, there is levers on the bit side, and the levers is software. But there are two kinds of software that I think actually will be game changers here. And Fayez and team are going to be talking about this later today. But the first is what I call live DFM. So if you think about what's been happening in the last 10 years, a lot of the infrastructure used in manufacturing has actually been digitized. So 10 years ago, if I got a robot, sometimes I wouldn't even have a digital representation of that robot. Today, if I get a robot, I actually have a smart digital representation of that robot. But then today, the processes that we still use to do simulation is still a lot of humans in the loop controlling this digital representation. And the advance in technology now will be able to allow us to actually eliminate some of the humans in the loop because of taking advantage of the digital infrastructure to automate that loop and eliminate the loops I talked about. So I think for the first time, we can do what's called live DFM. And live DFM, typically I use this example with folks who don't do manufacturing. But if I ask guys, like, when was the last time you did manufacturing? Most people would tell me, well, I haven't done manufacturing ever. And I ask people, when was the last time you printed a paper? Most people would say, I printed a paper today. Well, 50, 70 years ago, that was in a factory. And if you think about the process of printing a paper and how that has been domesticated, Some of the technologies enabling that are also now available for people who are doing multi-process manufacturing. And the first one is, think about print preview, right? You're asking about manufacturability feedback. Print preview, which you use every day, that is designed for manufacturability feedback. We just don't think about it that way. But print preview on your computer is telling us, this is exactly what my design is going to look like in physical form. I think with the advances of software, and there's evidence of that, we started leveraging that today, I think we will have live DFM as a capability, and this will be available regardless of whether you're a big manufacturer or a small manufacturer. But imagine the future where someone is designing a product, and they hit a button, and they get feedback immediately on whether it's manufacturable or not. So that's the first part in collapsing 0 to 1. The second, and actually just as important, and I think this will increase the survival rate for a bunch of companies, is actually what I call orchestration software. Again, using my analogy for printers, from the moment you look at print preview and you're good with it, you hit print. What happens from the moment you hit print to actually a printer, and it's agnostic of what printer you're using, actually prints out your paper? Like, that is orchestration. It takes a design intent, translates it into equipment instructions, and then in a universal way hands it over to an equipment that executes. We have the same capabilities today in manufacturing. So I can go from a design of a product in CAD, I can translate that, and a bunch of startups now are investing in that technology to be able to translate a design intent into manufacturing process into manufacturing instructions, into equipment instructions, down to the PLC, down to a robot program. Again, back to Suzanne's point, if we eliminate the cost of training, the effort of training robots and automation, of changing when there's a change in the design, the cost, the time it takes for us to be able to change the equipment to the process, if we eliminate that, it becomes seamless. It's like the way we do it in printing today. But if we bring these capabilities to multi-process manufacturing, we're now leveraging software to completely collapse that time from 0 to 1 and 1 to scale. And so software-driven manufacturing, just like we say, what is next-gen manufacturing is no manufacturing, but it's actually software-driven manufacturing, where software becomes the key enabler for manufacturing. And that is evidence in terms of the teams. When I was at Nissan, 0% of the people I worked with were software engineers. In fact, I used to think I'm a pretty good software engineer. Then I moved to Bay Area, then I met real software engineers, and I found out I wasn't any good. But then at Tesla, about 10% of my manufacturing engineering team was software engineers. At Rivian, that number was 40%. And I think that if you're building new manufacturing capacity today, the reality is more than 50% of your team is going to be manufacturing engineers, because that's where the levers are today in terms of being able to scale fast. Thank you.